I'm Simone di Filippo. I'm a PhD student from the Observatory of Padua. Today I'll talk about the Ingot Wavefront Sensor, which is a wavefront sensor for laser guide star. And the subject is the optical design and some preliminary tests. As we know, the laser guide stars pretend to be like natural guide stars, but they have some problem, let's say some issues. Like they are not point source, but there are some SIGARs or maybe something else. They are located at finite distances, and they are defined in a 3D volume instead of point source like an NGS. And this means that sometimes, for example, they will not focus on the one focal plane, but different focal plane like this. As you can see, the middle part has the best focus on this plane instead of the upper part and the lower part that are the focus on this plane. The actual design of the ingot is this one. We are moved from a 6 pupils configuration to a 3 pupil configuration. It's made by a reflecting roof. There are that has two faces like this. And the idea is that some part of the light which will reach the two faces of the ingot, they will be reflected, forming these two pupils. And the other part of the light will not touch completely the ingot and will be transmitted in order to have a third pupil. These are some of the equations for the signals that we are using, but we are still working on to find the best one. So here, if we consider the telescope pupil, this is a configuration of the ELT. If we look for two subaperture, one near the laser launcher, which is this one, and the other one on the other edge of the telescope pupil, we can see that, for example, in the subaperture A, we will see the LGS under a really small angle instead of the other one, which is easily bigger than the first. And the subaperture A, the LGS will produce in a Jacques-Hartmann, let's say, like this cartoon, a perfectly circular spot, like they. On the other side, we can see that in the subaperture B, it will be produce an elongated one. So it's easy to understand that we can have different aspect ratio for the source, which we have calculated for ELT framework like 1:1, 1:15, and 1:30. Sorry. Another thing that we need to understand is that the ingot, seen from different subaperture, can be represented in a different configuration, different projection that are shown here. For example, this is for the subaperture A, which will see the LGS, as I said, with a source with an aspect ratio 1:1, which is that one, the circular spot. And the ingot is seen from the subaperture A with this mask that has an angle of 30 degrees. In the other case, from the subaperture B, the ingot can be seen with this mask, which has an angle here of 0 degree. This is what we use in LAM to test the ingots in the loop bench. We have considered 3 different cases that we represented at T0, T15, T30, which is, again, the angle here, 0, 15, and 30. And we simulated using the SLM, the spatial light modulator, and this is as you can see, the particular draw of the bench from Pierre. What we use, what was important for us was just the DM that we used to apply the turbulence, low-order turbulence, the Jacques-Hartmann that we used to calculate the residuals, and the SLM that we used to simulate to the phase mask of the ingot. We were able to collect some data, and that are shown here. We can see the open loop here, data, and the closed loop for some of the configuration cases. In the same time, we are developing a simulator in order to come back again to LAM and to collect all the data that we need. Here you can see two different configurations, T30 at 1:7 source aspect ratio and 1:1. On the left there is the input wavefront, and on the right the reconstruct one on the end. This is the source, the aspect of the source, and this is the flux on the three pupils. Again, also for the simulation, we have two plots. These are for the same that I showed you before, T30 at T30 at 1:7 and T30 at 1:1. They are both open and closed loop. As you can see here, for example, we had still problem to close the loop. In the simulation, we have some instabilities that we are working on. In the same time, we are developing a bench in Padua, the Observatory of Padua, to test the ingot. Sorry. And it's composed by two lenses. We have diaphragm, the source here, which reproduce the LGS, and the ingot. For the source, we are using, as you can see, an iPad, which is on which we applied a black cover in order to block the light from the background. This is one of the problems that we have. And the ingot is positioned on an hexapod in order to have the 6 degrees of freedom. And we were able to collect some preliminary frames of the system. A test that we made is to understand how the ingot is sensible to aberration, to Zernike aberration. To do that, we use a deformable lens, thanks to Stefano Bonora. And we were able to apply some aberration and collect some data. Here we can see some of the data that we collected in order to check with the simulation that we made if we are, let's say, if we are enough sensitivity. So here we can see a trefoil signal, Sx and Sy, at different amplitudes. They are made considering a random subaperture on the pupil. And we can see from this plot that we are, let's say, we have enough linearity. We still have some part that is not so linear. Then we are working on. Thank you.